Enterprise Management 360.
Hello, my name is Matt Aslett, Research VP for Data, AI and Analytics at 451 Research, and I will be moderating this EM360 podcast. Most companies are increasing their investment in data processing, analytics and machine learning software with a desire to become more data-driven. And we see that data and the rapid processing of data is a key driver in enabling companies to grasp the opportunities presented by digital transformation to deliver things like operational efficiencies and competitive advantage. A recent 451 Research Voice of the Enterprise survey of enterprise users showed that 84% of respondents said that at least some of the strategic decisions at their organizations are data-driven, while 95% of respondents said that data will be as important or more important to their organization in the next 12 months. So data is increasingly important to almost all organizations. Those that don't recognize the value of data and invest in it risk losing out to those that do. Recognizing the importance of data is one thing. Doing something about it to enable the organization to act upon it is quite another. And enterprises really need to take steps to ensure that they create a culture that enables the company to be data-driven. Our Voice of the Enterprise survey also highlighted some key differences between the most data-driven and the least data-driven companies in terms of things like their attitudes to data, the products and services they're using, and the ways in which they're embracing cultural and organizational change in order to enable more data-driven decision-making. One particular area of focus in recent years has been self-service analytics and visualization, which promises to deliver the democratization of data and analytics, the long-held promise of BI for the masses, by lowering the barriers to putting data into the hands of the people who need it most, senior executives, business users, and knowledge workers. Today, I'm pleased to be joined by Jon Walls, Enterprise Data Consultant at Looker, to discuss the opportunities related to self-service analytics and how to deliver the benefits without sacrificing data governance or unified metrics.
So, good morning.
Okay, good morning, Jon. Thanks for joining us. So Jon, let's start with, self-service analytics has been around for some time. Of course, the benefits are fairly well understood, but perhaps a refresher for those who are not involved. What are the benefits? But also, why do you see that perhaps in some organizations it hasn't been more widely adopted? What are the barriers to adoption as you see it?
Sure. On the benefits, it's always difficult to identify precisely what the contribution has been to the bottom line, from analytics. But you mentioned some survey data in terms of how it's considered important. And as another example of that, last May, McKinsey did a survey of 1,000 companies with over $1 billion of revenue. And one of the characteristics of the best performers, the breakaway companies as they put them, was that they were 13 times more likely to be spending more than 25% of their IT budget on analytics. And one of the characteristics of that spend was what they call conquering the last mile. In other words, empowering the front lines to make data-driven decisions. And that's where that self-analytics piece is coming in. Just this idea that decisions throughout a company should not be based just on gut instinct or received wisdom or the loudest voice in the room or whatever. And examples that we'll see of that are things like, how do we do targeted customer segmentation if we're doing an email campaign? How do we reduce churn in our user base? Things that individual managers will be making on a week-to-week basis, not just big strategic decisions, once a month or a quarter. Ourselves as a SaaS company, we use it, I'm partly on the revenue generating side, and it's nice to have access to real numbers, up-to-date numbers on, for instance, who's likely to churn, who is having a bad time for whatever reason and deserves some extra help, whether that's with technical issues or adoption issues. And adoption really is the big area that we see the biggest challenge, as you touched on. And you'll see evidence of that in things like, high volumes of ad hoc requests being passed to the data team. In other words, the business users aren't feeling comfortable or aren't feeling capable of doing it themselves, that they can't do self-service. So they just push it back to the data team to produce that dashboard, to produce that answer for them. We believe at Looker that probably the single most consistent reason for people not being able to answer their own questions is a lack of consistency, a lack of reliability in the metrics. We call this data chaos. And it's not necessarily that they haven't tried to get an answer. It's just that they have a different answer to one of their peers in a meeting. So they both have, if you like, their equivalents of their own spreadsheets or their own dashboards that they've made themselves, and they clash. The numbers are different. And suddenly, you're spending that meeting talking about what the number should be instead of what the decision you're trying to get to. Even if perhaps the numbers are close enough that it doesn't actually make much difference, people don't like to see that conflict. So the real success of providing self-service tools is where you recognize that there used to be this kind of old idea that self-service was really, I didn't have to ask IT, my department was able to do it myself. And that's kind of how self-service was judged. But now, as we're seeing more of a spread of this data-driven decision-making, it's down to individual managers to be able to do their own quick queries and reports instead of asking someone within their department to do it for them. Because you see lots of dashboards out there doesn't necessarily mean you've taken on self-service, because those could be conflicting, and it could mean that you've got problems that still need to be resolved by IT. So the base of it, we'll talk probably more in this, the importance of data modeling and things like that can give you that consistency and reliability. But really, it's by focusing on the end users and making sure that they've got an interface that is as simple as it can be for them and helps them get to consistent answers, not just answers for themselves, but answers that kind of agree with the other departments that they might be working with. At the root of it, this is about an expectation. So there was a wave of self-service analytics, say around 2010, but once, say, Tableau and Power BI really took off in the marketplace, that we saw there was a huge appetite out there for departments to be able to do their own analytics without relying on IT. And where we're going is expecting people not to have to rely on a specialist in their own department either, but actually being able to do it themselves. So, a big focus on more the adoption and the issues around adoption rather than data visualization and dashboards as such.
We've seen that. We've talked a little bit about sort of almost managed self-service. There clearly is that balance to be struck. And, another area, I think, where we see the need for balance. One of the primary reasons for good data governance is, for example, to ensure compliance with regulatory requirements. And I think that's something companies can struggle with. Well, how can you balance that with, if you're doing agile self-service analytics? Clearly there is some, a middle ground to be found somewhere.
Yeah, and that balance really is important, and it's important to recognize there is one to be struck. I mean, there's always a general perception that the word compliance or audit, another one, leads to expensive red tape. And it's certainly a risk if you are in IT. It's not just the data thing. Also, if you're in HR and your finance, if you like the shared services organizations or the corporate departments, you can get a bit of a reputation as the department that likes to say no. So you've kind of got a responsibility to be taking a positive approach to what compliance means on both sides of the fence. Because, one of the things that's always useful to bear in mind is that security and auditability, the things that you need to do to get those are also quite often the same things you need to do to get high performance at scale. In the tech sector, at least, a big example of that was Facebook. They used to have the Silicon Valley philosophy. Their internal motto was move fast and break things. But then 2014, Mark Zuckerberg started giving interviews where he was saying, well, actually, we've changed that now, and it's move fast with stable infrastructure. And that stable infrastructure, that ability to deliver value consistently, is kind of where you've got an ability to make the most of the things you also have to do for compliance. Simplicity is nice for end users. That's important for self-service analytics. And one of the requirements, if we use GDPR as an example, is you should only have the data that is relevant to that individual, that is relevant to your business and what they do with that individual. So we start to see some overlap. Messy data is bad for compliance. It's also bad for self-service. We see a push towards centralized data. So if you're going to be responsible and have to report on your ability to say this data is safe, it's secure, and it has access controls, well, you can't do that if data is everywhere. So you have to choose, certainly for long-term storage and probably for all analytical requirements, a small number of places where that data can reside, ideally centralized, quite often in the cloud these days. And that centralization makes self-service analytics easier because joining data together is easier if it's cleaner. That'd be the top level message I would give is when people talk about governance and compliance, look for the common ground where you're both going to benefit, both on the business side and on the compliance side, from having better, more stable, more reliable processes in place. And then there's also the aspect of you do have to recognize there are going to be conflicts. Everyone has had that no answer that they don't necessarily want to hear. And that's where your work processes come in. So the more agile you can be as a data team in terms of responding to new requirements, so that at least when you say no, it's not because you're inflexible and can't change, it's because you actually have a reason for doing so. Having that collaborative approach so that when you're talking about data sources, data models, dashboards, data pipelines, whatever the question of the day might be, that should be something where the business users, the decision makers at the table in the same way that the data engineers are. It's not always the way things are done, so that's kind of where you should try to get to. And it's in that collaboration that you're going to get that, hopefully finding more common ground than conflict when you're trying to strike that balance.
As you said, clearly there are different users with different requirements, and that's where conflict is inherent in that. But obviously, hopefully, there is the opportunity to find some common ground. I was interested less in terms of perhaps from a data usage standpoint, but more around sort of just from an interface standpoint. When you've got multiple users with different BI requirements, quite often, most organizations have got therefore several different BI tools, for different user groups. Is it really possible, do you think, to have actually a single environment with different interfaces that address all those different individuals within a company? Or should organizations just accept that, they are going to have multiple tools providers, but perhaps try and, limit the number of those?
Sure. Certainly on a personal basis and the way that the teams I work with talk about it, let's accept the premise. Large organizations are going to have multiple BI tools. And the one example I give just in terms of how unavoidable it is that if you merge or acquire another company, bang, suddenly you've got two environments, no matter how good a job you've been doing. So, the problem is always going to be there to some extent. And even within that single environment and with the different interfaces and all the rest of it, you might still have graphic designers producing online content, which is one use of analytics. You'll have data scientists maybe doing exploratory analysis with data they have found. So there's always going to be an element of multiple tools for the right job. But you should be trying to make sure that's kind of an optimized application portfolio, if you like. Don't have everybody using every tool. Make sure you're using the right tool for the right job. And then, to your point, can a single environment deliver multiple interfaces? Is yes, absolutely it can. The way we structure our engineering teams, we have a business intelligence team and we have an applications team, precisely because we think it's important that you should be able to build different kinds of interfaces on top of your data. That, the business intelligence experience, if you like, is not always the one that you want to deliver. We talk about having 110% API coverage, which sounds very hypey and probably is to an extent. It is a marketing tagline. But the point that we're trying to get at there is we know even if we provide the perfect data platform and the perfect data model and so on, there are going to be interfaces that reflect processes, end user needs that we haven't anticipated, and we'll never be able to anticipate as much as our customers can of their own requirements. So it's absolutely critical that you don't see yourselves as providing the interface to the data. You should provide the capability to have multiple interfaces because people are going to get their data through multiple routes, at least from their point of view, and they're going to want to do different things with it. And, we shouldn't be trying to predict all of those. So within our own customer base, we have teams that have built their own entirely custom ad hoc query interface on top of their data, because there's aspects to their business that are completely predictable in terms of structure and hierarchy and things like that. And they want to build them directly into the interface, into the menu options, in a way that we just can't on their behalf. We even have people using our modeling layer to generate SQL queries to insert into their in-house tooling. So we never connect to the database at all. We're just doing a purely modeling function. So it's quite interesting, once you get into what different teams need to do, even within the single company. And while you might never be able to get to that one single environment, you should absolutely, as a data team or a BI vendor, have an aspiration to say that within your environment, at least the one that you can control, you are not placing restrictions on the variety of interfaces that can sit on top.
That latter point there, it's a good one in terms of, clearly it's not just about the interface, it's also about, the ways in which different groups within an organization are working and their existing workflows. Clearly, and I think we've seen this before with self-service, has been adapted in some organizations very rapidly, but in pockets. And if you're going to really drive this out across multiple constituents, those constituents, they need to see that it's going to work for them without them having to change the way in which they like to work today with whatever tools they might be using. So, how do you think sort of more at an enterprise-wide sort of level, organizations can provide, access to data for all those different groups across the organization, but in a way that fits their existing workflows, if you like?
Sure. And the workflow is a great concept. It's a great word to have the discussion around. In part, it builds on your previous question, which is, if you've got multiple interfaces, but if you're talking about the same data in the background, then suddenly you've got a workflow going across different interfaces, but you could still have a consistent single data platform driving that in the background. So that's one way to look at it as a kind of variation on the previous one. And the other is, I guess, when talking about what if we do have different environments, or what if we haven't got to the place where we have this, wonderful single environment across all 200,000 employees of a global corporate, that kind of thing. Because, of course, realistically, that's not going to happen. So delivery and integration becomes important. There's a couple of aspects to that. One we've been talking about there, which is just the interface. So can we perhaps embed bits of the analytics platform, little bits of the interface into the different tools that people use? So for instance, in the team I work in Looker, probably the most common way of people in my team seeing Looker is the bits that are embedded into Salesforce, because we're in an account page and there's some information relevant to our customers there. So, why log into a dashboarding tool when what you're really interested in is some information with respect to where you are right now? And on the customer facing side, we live in Salesforce, and there's equivalence across the business. So there's that embedding aspect. So not necessarily a completely new interface, but just embedding bits of one tool into another. And the other is around delivery of the data to other places. So that might be messaging. So email and Slack on the instant messaging side, we see as being, the most popular way to get data out. And we're quite keen on whether it's going into a cloud storage bucket, because then it feeds into another process. That's fairly popular with data scientists, or sending segmentation data into Marketo or something like that. There's all these examples where people start with doing an analysis, but that's only the start of the process. The workflow they really care about is the email campaign they're about to run. It's about the churn reduction that they're targeting for the end of the year. It's about their, whatever their actual work is. That's where they want to get their data. And your ability to provide these integration points to support all these different output formats that people want, to support APIs, the API economy, as MuleSoft used to call it. These are all important parts of what a data tool has to provide these days. And it's hugely important. So we call that powered by Looker, when we're really focusing on getting data out of one environment into the next, maybe sharing it with the supply chain partners, for instance, sharing via a portal. It was our biggest growing segment last year. It's a significant part of our revenue stream. So that workflow idea, very important. And it's around not thinking that you are the one environment, really, but that you have to play well with others.
Right, absolutely. And I think, that, as you said, that's been a really significant change, obviously, in particular in the last couple of years, in terms of multiple users within an organization now engaging with the output or with business intelligence technologies without necessarily sitting in front of clearly a dashboard. And we talk about pervasive intelligence and just intelligence flowing through the organization. And clearly easier said than done, but we see a lot of organizations working towards that. So changing gears a little bit. Well, I suppose it's related in a way, less so in terms of the multiple outputs, but multiple inputs. One of the big changes we've seen over recent years is obviously more and more data sources that organizations are trying to take data from, not just their enterprise applications, but obviously, could be external data sources, obviously Internet of Things, numerous. We think about that in relation to the traditional data warehouse approach. I mean, that was, obviously highly performant the analytics models that you generated when you created that environment, and good at answering queries that you knew in advance you wanted to ask, but quite inflexible to change. As data sources and the queries change, obviously we've seen a lot of organizations almost have to go back and rebuild, for everything from scratch, which obviously isn't particularly efficient. How do you see that enterprises are addressing this? Enabling business intelligence based on changing data sources and accepting, data is going to be continuously updating and having to model and build for that.
It's a big challenge. It's probably one of the most interesting areas at the moment because there's been so much change over the past few years. Looking at it from the perspective of where does all this data end up, one of the big waves recently, we talk about it at Looker as the data infrastructure revolution. Because as you mentioned, there were these data warehouses of the past. They were extremely good at providing reliable data and accurate data and trustworthy data, if you like. However, that was at the cost of what today would be considered a slightly heavy-handed approach to data pipelines. So we're seeing storage change because as we see just the price performance of massively parallel processing databases, MPP databases, has changed dramatically. We are seeing BigQuery and Redshift and Snowflake, this big Azure data warehouse. The big cloud providers are providing a very different way of looking at data, which in the way it separates storage and compute basically makes it cheaper and more flexible and easier to start pushing data into. And that has partly come from there's been a big change on the data side. The NoSQL revolution didn't really quite turn into as big of a wave as it might have thought, but it did start changing this idea that you get the schema when you read the data, not when you push it in, completely turning traditional data warehousing philosophies on its head. Another thing that's been changing is we're seeing all these SaaS applications. So SaaS, Salesforce, Marketo, Workday, ServiceNow, there's a range of enterprise applications out there available as SaaS products. That's been building for quite a while. They're not brand new, but the depth of adoption into the enterprise market keeps increasing. And what's interesting about that is suddenly we have actually relatively well-known data sources from one company to another. As customizable as those applications are, we're starting to see SaaS pipeline vendors like Fivetran, for instance. You can actually get from a CRM system to pumping data into your cloud data warehouse in something that you start to measure almost in minutes, certainly not weeks. So there's a big change happening there. And we started to see that impact of that reflecting in mergers and acquisitions. So Google just announced intent to buy Illuma recently. Talon bought Stitch, so that was a traditional data integration player, buying one of the new players on the scene. So 2 points I'd make out of all of that. One is there are these new capabilities and new expectations that you can meet that if you have, if you like, an off-the-shelf SaaS product, even with some customization of the data model, there are now tools that will quickly get that data into a data warehouse for you. And you should be trying to raise your expectations of how fast that work can be done if it's not particularly custom. So that's one point. But the second is integration isn't going to go away. Things that are critical for your business, data flows that are coming out of your core activities from your supply chain, maybe. So talking cloud terms, you might have a Kinesis Firehose or a Kafka stream of data that is not coming from an off-the-shelf application, but is something that is very particular to your business. So in those cases, you're still going to want the traditional capabilities around data pipelines and getting that data clean and ready to put into the database. But now you should be looking to focus that kind of project on things that are truly critical to your business instead of being in the more unfortunate position that we used to be of having to do that for everything. So you can kind of take a blended approach to minimize efforts where you can, and for the more complex jobs to only do that where it's actually core to your business.
You've mentioned a couple of times in passing sort of the importance of modeling and data modeling and the role it plays. In particular, I was interested in that in terms of the democratization of BI, because I think data modeling clearly is something that's been around for a very long time, but it's perhaps been seen traditionally as something that was only relevant to the power users with specialist skills and not for necessarily the masses. How do you see that evolving and the role of data modeling with the, particularly in relation to democratization of BI?
In the same way that we recognized there was this wave of self-analytics, just new tools and applications that came out and just changed expectations of the ability to do self-service. Even before that, there were companies like MicroStrategy and Business Objects really demonstrated that a good data model is a really powerful way of getting reliable information. As we often say, the right information to the right person at the right time. To get all of those things right, you need a data model of some kind. It can't be a completely self-service process driven by the end user who doesn't necessarily have or want to spend the time learning the skills of statistics and analysis and so on. So data modeling is critical, but as you say, it was very much a specialist skill set before. And that first wave of tools, they brought this incredibly valuable concept onto the market. But also, it would only be the specialists, typically within the IT function, that were able to make anything more than very minor changes to that model. So every change from a data perspective essentially has to go back through IT. And that caused the frustrations that led to the self-service revolution. So we think the challenge is, so how do you keep the value of data modeling, that accurate, reliable, consistent information, and yet still have the flexibility that you want, as seen with the self-service side of things. The approach we've taken, the kind of like one of the founding assumptions of Looker, so we think it's pretty important, is that the language of analysis is SQL. It's proven to be a tried and true way of analyzing data, and even all the NoSQL databases now either have or are developing some kind of SQL layer, because that is the language by which business user questions can be asked, as well as more sophisticated analysis. So that's the first step on the way we approach it, which is, well, let's take this language that is very proven and actually incredibly well spread. So unlike having a certified architect in an IT department, which is very unlikely you're just going to come across someone with this specialist certification in finance or in marketing, what you will find in any finance or marketing function is you're going to have some data analysts there, and they're going to speak SQL. And if you're rolling out a serious self-service capability, if you don't have someone with SQL skills, you're going to find it's a very widely available skill set on the market, and it's not an overly expensive skill. Obviously, the better the architect you get, it gets more expensive, but core analytical skills in SQL are actually just the starting point for being an analyst. So we build a modeling layer on top of that. It's version controlled. It's based on Git. And not to talk about that so much, but it's based on the idea of collaborative development. So you can have a core model. The most difficult parts, if you like, can be maintained by centralized teams. But because we've got a collaborative process in place, we can allocate parts of that model out so that finance or product line A or product line B or the marketing team, they can have the skills they already have in terms of data analysis and, help maintain that model and bring everyone's domain expertise to the table instead of having kind of what we used to have wasn't just data modeling as a specialist skill, but it only lived in the IT department. So you kind of lost a lot of the knowledge that you had in the other functions. Because, finance and marketing are very data-driven functions. They have great analytical capabilities there, but it's very difficult to leverage those skills and use that to build a really good self-service experience for other users if you don't have some kind of modeling approach where you can get that knowledge, get it into a repository is our approach, and then share that out to everybody else for the self-service. Last point I would make is the data modeling. We think one point's really important: never show it to the end user. The end user shouldn't need to see it. It should just be exposed to them in the form of a familiar graphical interface. So, that thing doesn't go away. The modeling isn't for everybody, but it is for more people than it was in the IT department previously.
In some ways, there's kind of analogies do you see where a lot of companies at the moment obviously trying to invest in data science, and I think some of those literally just hiring a group of data scientists to perhaps sit in a room and work their magic. But if we look at obviously the enterprise landscape, so we estimate there's maybe 1 to 2 million data scientists in the world, and you can compare that to roughly maybe 50 to 75 million BI users, 250 million knowledge workers. So clearly, obviously, each organization is different, but there are more people who aren't data scientists, obviously, than those there are. So my companies are investing in data science. I mean, what do you see? How can they also ensure that they combine the results from that data science work into their existing processes and put the, as you say, kind of the outputs of that into the hands of the business intelligence users and the knowledge workers, and make sure it doesn't become just a silo.
Yeah, and data science has seen that the peak of inflated expectations, as it's also called, and there's been a little pain with things that haven't turned out too well. But we can look at where there's been successes. I'd say probably a good place to start is with the staffing. So if you look at what's a data science project going to involve? Well, if it's something that's going to make an end impact on a business, or if it's really going to optimize a process, sure, you'll have a data scientist, but probably they have a reliance on some engineers or analysts to be providing the data they're going to work with and who can consume the outputs of what they do. If you're going to be focused on a real business problem, they'll have some kind of product owner or business sponsor that they're working with. And if it's going into production, quite possibly you'll have admins around, maybe even go as far as having a developer. So it's a very cross-disciplinary process doing good data science work. And that range of roles kind of gets back to what you're talking about in processes. So probably those people aren't all in some data science team. Probably there's some kind of cross-functional team has been put together. So there's going to be processes wrapped around that. In terms of operationalizing all that, you're going to need a few things. You're going to want some kind of platform architecture. That might be a combination of different things, and typically is, but you're going to want some kind of environment, where the data pipelines are running, where the outputs of business processes land, where the outputs of the data model or the algorithm that you're running, the machine learning model, also land. You're going to want to have a data-driven culture or a mentality around the idea that quite often these data scientists are going to be crossing across boundaries, and you've got to be able to share that data. Kind of gets back to the governance question. People have to feel safe that they can give access to other departments. Some of the data they have might also touch on the multiple interfaces thing. If people are going to trust and use the output of the scientists, probably that data or something around their recommendations or the classifications or its forecasts, whatever it might be, that's got to end back up in the interfaces that they are using. Otherwise, the scientists are just somewhere off in a corner and being invisible, which means that even if they find something useful, it's not going to get leveraged particularly well. And overall, we call that wrapping that up into a data science workflow. We provide a platform that you can get data out of, and that if you put data back into a centralized warehouse or something like that, we can start sharing that through all the different interfaces. So we look to provide half the solution, if you like. And then what we're looking for is the things just mentioned. Do you have the right culture in place? Are you building the right teams? Because there's a variety of skills, not just the mythical data scientist. There's a bit of a mixture there, and do you have the overall processes around that so that they can get the data they need, do the experiments and find the learnings there after, and then implement that in production. I think my favorite little example of that I've seen is quite a small one, but it's just a gaming company. And they place adverts online. So they need to predict the value of their keywords. So, they need to run a forecasting algorithm. And all the forecasting is done by the data scientists. So they have, I think they use Python, but, they've got a series of models that they've built initially in a notebook environment. That gets into production. And that is taking data from the production data environment, and it's feeding the forecast values back into that production environment. And then the actual process of placing the bids is automated using APIs. It's a nice encapsulated example of how, once you've got your processes in place, it can cut across actually quite a few different parts of the business and deliver real value to the bottom line.
We've seen several examples of that sort of approach, and I think one of the things that we've seen as across the industry as a whole is that more organizations are trying to store and process more data. We talked about more data sources earlier. And one of the things in particular from 451 Research Voice the Enterprise surveys has highlighted that actually, currently at least, the more data organizations attempt to store and process, the greater data access and preparation is seen as a challenge. And clearly, this is work in progress around this. But how do companies ensure data preparation doesn't become a barrier actually to insight, or at least a delay to insight?
Sure. When the big data wave happened, the original three Vs are still very relevant. The volume, variety, and velocity of data. It's this overwhelming fire hose. I mean, I like to start with a bit of an analogy from a very different area. My partner, she works on the scientific research side in physics. She's an astrophysicist herself, but recently she was working for a thing called the Diamond Light Source, which is called a synchrotron, but it's basically a particle accelerator. Whiz particles up to the speed of light to generate these very pure X-ray beams. And these things generate phenomenal amounts of data. You can think of it as an X-ray machine the size of Wembley Stadium. So they've got lots of equipment. They've got incredibly powerful machines. They've got extremely numerate people. And they still need to figure out what data to throw away because they just can't store all that data. And there's a broad lesson in that applies to industry, which is that you can't keep all of your data and process of all of your data and find insights throughout all of your data. You're going to have to do a little bit of focus on what the insights you're looking for. And of course, you don't necessarily know what insight you're looking for. So that really means what's the business problem you're trying to solve? And you're probably going to have to prioritize. Now, with cloud computing, with the Hadoop revolution in terms of commodity hardware for processing data, you can still store a phenomenal amount of data. You could put it on relatively cheap storage if you don't know what you want to do with it yet. But seems to have been struggles to get value out of big data projects. The idea of just pumping all of your data into a data lake and you'll find out what to do with it eventually is probably falling out of favor. So you've got a little bit of leeway in making your decisions, but don't just have a data swamp. Have some idea of what you're using it for. And certainly something like Hadoop can handle unstructured data in a way that data warehouse just can't. So, so there's a clear differentiation that you can make between the different tools. But that's just storage. And your question was about preparation. So the real thing with preparation is that, one, leverage those out-of-the-box capabilities if you can. If it's a SaaS application that's well known, just reuse what's been done before, and then focus your capabilities on the things that are special or unique to your business. And the idea we mostly talk about ourselves is the idea of lightly transformed data. So instead of extract, transform, load, we are now into extract, load, transform. So don't do too much to the data. Get it into one of these cloud warehouses that are going to separate storage from compute power. So it's still cost efficient, but it means you can start displaying data to business users without doing too much work on the modeling side. And then you can start iterating. So if you can do a lot of your cleanup or transformation work at the point of delivery, during that last mile to the business user, you're able to move a lot faster. You're reducing the workload you're doing on the pipeline. And you can more quickly get to this point of saying, is this number useful to you? Now that we've cleaned up the data and presented it to you in a dashboard or an ad hoc query interface, have we got the model right? And then sometimes you might push certain transformations back into the pipeline, but don't do that work until you've validated it by a business user. So it's kind of a way of using the new infrastructure that's available to shift that ETL to ELT and take a slightly more business-focused process of understanding what actual cleanup you need to do. Because it's amazing the number of times, you can do a lot of work in data prep and then the data is never used. So, you can flip that around.
Yeah, absolutely. I mean, it's kind of interesting, isn't it? Clearly there's been a lot of change in this industry, particularly in recent years. As we talked about, processes changing, technology is changing. Obviously, the consumption, the way in which the analytics is being consumed, changing. Some things, remain the same, which is fundamentally what is the business problem you're trying to solve, and then obviously architect to do that as efficiently as possible. So just to sort of finish this up here, we've been talking about obviously the state of play today and how it's evolved. Interested in your perspective of how that will continue into the future. I mean, what do you think the future holds for this space in particular?
Well, certainly where we're placing our bets is around that idea of multiple interfaces, but taking it further. So it's not an original observation, but it used to be laptops, mobile phones. You would see those in the hands of industry and business folks before they got into the consumer. And now, the last 10 years or so, look at Google Mail or Apple iPhone. There's all these other examples of consumer tech actually is leading the industry tech. And if you look at the consumer experience of data at the moment, we're seeing wearables, the Fitbits of the world generating personal health metrics. We've got interactive phone bills online. People who have smart meters now have a web interface to see, the usage of energy in the home. And in each case, you could say that what's interesting here isn't so much the data, it's the fact that we've got an entire interface that is being crafted to serve that particular user, possibly on a particular device form factor, where they are, trying to make that user experience as simple and intuitive as possible. So there's always going to be a need for kind of the richness that you have of a true business intelligence application. So we are certainly going to continue developing ours, and we expect others to in the marketplace. But there's going to be an ever-increasing expectation that the enterprise experience of data and analytics can be delivered to business users, people on the shop floor, as well as decision-making executives, with that same focus on that individual user experience. Whether that's of the things we are seeing today, in the sense of we have APIs so people can build their own interfaces, but assuming that trend does continue, it's going to be important for us all to make sure that the way that we build, deploy, and maintain those end user experiences is going to be as flexible as possible for our customers. And at the root of all that, there's this fundamental change in expectations. That thing I mentioned about the decisions at the shop floor, as well as for senior managers and execs. So if you want to achieve that, if you want to transform the user experience of how they interact with data, you kind of need to re-engineer all the processes that are happening behind the screen. So, that's the other big shift, as well as seeing things at the interface level. If we are going to see that change in BI, it's going to be its own little digital transformation for the BI industry, for the market. And it's going to mean that, as well as analytics, we're going to have to start thinking about things like design thinking, to say, what is it to make a service, BI as a service? What does that mean? What does it mean to provide technology to customers that actually have to essentially build their own products that they are providing out to their end users, all those multiple interfaces. So that under the hood thinking is the big change that's going to make that big change in interfaces possible.
Absolutely. Well, thank you, Jon, for the conversation and the insight into self-service analytics and fighting the data chaos. I think it's been a really fascinating conversation, much perhaps to follow up on there. So, Jon, thank you very much for your time.
Well, thank you. It's been a pleasure.
Great. And thank you, everybody, for listening to this EM360 podcast.